Okay, great. So let's get started. Just doing a brief introduction to myself, and I'm Christina. I'm the new JBoss technical evangelist, and now I own the Fuse and AMQ products. For those of you, or most of you probably know me in APAC. For those of you who don't, I used to be an SA in GCG region, and I have been in Java and financial industry around for a while. And okay, so let's get started with our Internet of Things and AMQP with AMQ. So what is Internet of Things? This is us 10 years ago. We used to have our own PCs connecting to the internet, and well, the number of devices connecting to the internet are limited because you're not going to carry a lot of computers around. Probably most of you would have like 3 or 4, but you're not logging on at the same time because you're at work or at home. So the number of devices connecting to the internet are limited, and most of it is with human interactions. But as the year progressed, the technology being advanced, we have a lot of handheld devices being massively produced, such as the iPad, iPhone, the smartphone devices that you have in your hand, and the Google eyeglasses, the Google glasses they have out. Well, they were out, and even the iWatch. I think Apple was supposed to come out in this WWDC, but it didn't. And the fitness. And the fitness ring that we have in today that are transmitting all our fitness records up to the internet, and the medical devices that are sending data into the medical systems, and even our home appliances are sending information up on the internet, which is a lot. So imagine one person having all this device and gadgets around themselves, trying to connect into the internet. So not all of the devices are needs human interactions. So most of them are machine to machine. Some of them just automatically sends information up to the internet and things like that. So what do we do with this data? This data are crucial. They're raw, but they're valuable. How do we do it after we? What do we do after for this? What do we do for this data? And how do we cope? How do we cope the massive amount of data if all of the people, having all this device trying to connect into the system or onto the internet? How are we going to cope with the vast amount of information flooding inside? How does our system, does the hardware cope? Does our software cope? And how do we even filter out this information? How do we know it's useful or not? So all those things are the things that we're going to talk about in IoT. So, but basically, what IoT is, it's billions of interconnected devices that are trying to connect in together, and with well, those are machines, of course, and we have to measure and collect and analyze this data and make it to useful information sharing around. This is just a quote from Gartner. It's saying that by year 2020, there will be around 30 billions of connecting endpoints, and there's a vast 8.9 trillions in revenue for IoT. So this IoT is going to be a game changer for the most IT vendors. So we're going to see all the IT partners, such as the software developed. The service provider, the IT vendors, and even the semiconductors, and they are going to work more closely together in the ecosystems. And China, I think they will be a key player in the Internet of Things, since they have a lot of people and vast amount of devices they're trying to connect. They will have around 20 terabytes of data per year, at least by year 2030. So with IoT, implementing IoTs, are there any hurdles? What sort of things do we have to overcome, before we can successfully implement an IoT architectures? So one of the things that we're facing today is the lack of standards. This is a new topic. This is a new thing that many vendors trying to interpret and trying to implement themselves. So we have a lot of standards flooding around the world, and it's hard to integrate. It's hard to get all the system working together and making them work seamlessly around with each other. And there's the scalability. How do we cope with the vast amount of devices that's trying to connect to each other? How do we scale our system to get all the data in? And how do we make sure the security is all right? How do we make sure the data is being protected by our systems? And how do we manage and cope with the application that has been developing around IoTs? How do we manage their APIs? Those were the things that we want to, get over and trying to achieve, making people easier for them to use it. So after we get the IoT data, what do we do? Well, there's a lot of things. The raw data doesn't mean anything at all. So after we get the data, we have to either filter it, collecting it together, aggregating it into something that machine understands or even human understands, and integrate. Maybe we need the information to integrate with some of the other data from our own system. Say if we have a product number that we have gained from the devices, how do we know what product it is? How do we know what category it is? So with a single product ID, we have to map it to the database that we have, or a customer ID. How do we gonna integrate with our system? And after we gather all the information, how do we analyze it to analyze all the data and make it more readable for humans, so human can make smarter decisions? How are we going to do that? So this is where the Red Hat middleware comes in. We can provide, with AMQ, we provide a reliable and safety and efficient data collection platform, a message platform, which allows you to collect data. And we with JBoss views, we are able to integrate informations with different enterprises and make it easier to aggregate information. So aggregate all the systems together with Apache Camel and VRMS. We can use it to create rules and process it with business process and to make it more meaningful for users. So this is where our JBoss middleware plays in the field. So with this, okay, now number 2. So after collecting the informations, with AMQ, this is a real industry pictures. Either it's a medical or a logistic or electronic industry, whatever it is, it collects information through different protocols. So with AMQ, it has multiple protocols. It has AMQTT and AMQP and XMPP and even the native open wire and the stump protocols. So each vendor, they can choose whatever they want, whatever protocol they want to connect it to AMQ. And with AMQ, we provide a more reliable messaging system that allows it to have a flexible pool size, so it can cope with large amount of data coming in. So we can either extend the number of servers that's running AMQ, or we can minimize it when we don't need the number of servers. So with AMQ, we have the ability to be more flexible. So after we get the information from AMQ, we would use JBoss views because it's seamlessly connecting to AMQ. So we can camel routes to get information out from AMQ endpoints, and we're able to transform the data from the AMQ endpoint. We can transform the data into XML or even aggregate it into a more conformed data format that people need, and process it and route it to the right place it needs to be, or or maybe we can put it in somewhere that's more secure, maybe put it in a database that we're going to use it later. Or with data virtualization, it's we could simplify the complex data lookup, and it's easier for us to look up the information that we want with the simplified mode of how we're going to look up in data virtualization. And we can compose data from different data sources more quickly, and we can connect to big data solutions such as Hadoop. I think Kenny did one of the Hadoop connections a few months ago. You can look it up in his blog, I think. So with IoT and the more Red Hat solutions, we can use BRMS for rule building. So that after the data comes in, we can use rules to specify that what we can process without hard coding it into our programs. And we could put the data in data grid for a more flexible and more flexible data storage, so it's all in memory, it's easier to access. And I'm going to do a workshop tomorrow with Camel, with Fuse and JDG, that's going to get data out from database into JDG and later use WebSocket to retrieve the data. So if you're interested, we can do it tomorrow. And after that, all the informations can go into Red Hat storage, where they support Hadoop. Well, it supports Hadoop, so, and it all runs in Rail. So this is more a JBoss, a Red Hat JBoss approach. So when we come to JBoss AMQ, well, JBoss AMQ is a multi-protocol. Of course, it's host multi-protocol, and we're going to talk about 3 of them: MQTT, AMQP, and Stumps today. And it also provides a gateway for managing connections. So say, for example, if you have a lot of data coming in from the client, it's able to pass and route all the data from the gateway to the right server that you wanted to assign to. So you achieve a kind of load balance with JBoss AMQ gateway. And with that, it's as I said, it's easy to integrate JBoss Fuse to your AMQ because they practically runs in our Fabric 8, and it's easy to manage. Or I'm going to show you how to manage it later in my demo as well. So it's easy to make Fuse connecting to AMQ and process your data. So for the 3 protocol, we are going to talk about the first is MQTT. MQTT is a machine-to-machine connectivity protocol. So it's designed to cope with the extremely lightweight publish and subscribe message transport, which means that it doesn't have queue. It's a topic. So it's good for those devices that are remotely located, and it has small code footprints and limited bandwidth. It sounds like some of the devices that you wear or you carry around every day, where it doesn't have a huge computing power because it doesn't, and so it's not able to compute all this information. It's not going to hold a lot of information, but it's going to have some data, and all this data is going to be transmitted to your systems with very light and frequent messages. So what I mean by light messages is like very small bytes of messages. And the thing I can think of for the MQTT is for like the medical devices and the fitness devices that you often wear. They are very practical MQTT devices. So the companies that are already making MQTT to their devices are SCADA monitoring and GPS and GMS tracking devices, where they send all the geo points to your server and they track you where you are. And of course, it's always a standard, so it's standardized, which is good, always good. So you don't have to manipulate. It's not endologin or anything like that. For AMQP is an open standard application layer protocol. So it's basically a protocol on wire, For Java programmers, you probably won't notice it because you will be using JMS. So JMS is the coding API that you use, but underneath the JMS, often that we have right now today is that each vendor they are probably using their own technology to implement all the JMS technology, but now we have the standards. So it's everything from the top API to the bottom of the wire protocol is standardized. You could move around your code. It doesn't break your code or changes anything. So it's designed for more mission critical systems. So it supports a vast amount of communication patterns, such as point-to-point, publish and subscribe, and request and response, store and forward, such of things. Because it's designed for mission critical systems, and it's for large systems, so it supports scalabilities. So in the payloads itself, it has all the messaging information, allow you to be routing to different messaging servers, so it achieves all the load balance and so on forward kind of stuff. And you can always put in different kinds of data format in AMQP, like XML or text, even binary code. I think they allow you to put binary codes in and streaming media as well. So with AMQP, it supports a larger enterprise-based messaging wire protocol. So it's more like what you need in a business sense kind of view. And with Stomp is much easier. It's just simply text. So you could think of it's sending text over from client to our messaging server. So you're basically sending streamlines of text, of words to each other. By that, we could always use JavaScript or anything else to process it. So that's why we have a large number of languages that support Stomp, because it's only just processing text code. But it says on here it's lightweight, but I don't think it's lightweight because it's all text. So for text, it's, if you can compress it into a more smaller chunks, why can't we do that? But for Stomp, it's more for like easier implementation if it's loud and clear, and you have like different kinds of devices and languages that you need to integrate them together with AMQ, then I'll choose Stomp. But most of the time I would use AMQ or MQTT for smaller devices. And that's what I think. And this is, I have to thank Noel O'Connell for this. And he is the Australian consultant who's doing a lot of AMQ work in his region, and he's really good at it. And I asked him for the very last minute to share with me what sort of architectures that they're having right now in his customer. And this is one of the architectures he drew up for me. And I'm sorry if I don't say it right, but I'm gonna ask him about it in more detail, and I'll put it up in my blog, and you guys can come and see it later. But he's done a very good job in this. And for this, it's getting all of this information from different places, like getting flights information and planning out of database, or getting airplane information from a common adapter and other information as well. But for the end users, they're not talking straight to all these different systems. All the systems are integrated with our service bars and our field service work and AMQ. With AMQ, it allows AMQP, and it's using AMQP to push all the information out to airports and airlines, or they can use web services to get it inside. So this is what I get from them. This is a very, very good architecture. So now, what time is it? So it's demo time. I'm saying this quickly because quite nervous. So can you see my desktop all right? Yes, okay, great. So what I'm going to do here is I'm going to show you a demo that I did. It's called biomedical demo. The biomedical demo is this. It's simulating person's medical sensor that's sending out informations from the medical sensors, and it's sending out to the AMQ, and sending out to our messaging server with AMQP protocol, and our dashboard is going to get all the information out from the messaging server and display it on the dashboard that we have here. I have to apologize it because when I was doing it, I was trying to test it out on the AMQP protocol. But for the real case, I would use MQTT for this. It's not AMQP. I'm going to do another MQTT one if you want, but for now, we're going to stick with AMQP. It's easier. Okay, so how do you run this? This demo? First thing is I have to get it down from the so I have to get it down from the GitHub, of course. So I was just do a git clone. So it's cloning out all my information, all my codes out. So go inside. This is all the codes that we need. Before we begin running the init.shell, which is installing everything, we have to in the install folder we have to put in the AMQ product that we have before we install it. So in the product directory itself, just run the init.shell. So it's going to unpack all the AMQ and it's going to do the configuration of AMQ for you. Well, I'm going to tell you what I've did. So what I've done is that inside the support folder, I have two different files. The first one is the user.properties. So that's where I'm gonna add my admin users, because we're gonna look at it later. And this is how I create my users. And the other one is the ActiveMQ. Where is it? ActiveMQ.xml. The XML, it's just basic AMQ settings for my default AMQ, which are when I opened. But for this one, I'm going to add AMQP protocol on it. So this is how I'm going to add a new messaging protocol for my for AMQ. If you want to add an MQTT server, it's easy. So what you do is you're gonna put an MQTT, and it's going for MQTT. So what I do is I add an MQTT connector to it, so it's gonna talk in MQTT as well. But we're not doing this today. So what I've done is just that I simply add an AMQP connector to my AMQ, and I add my users to it. So that's what I did. So after that, you will probably see a target folder. So my AMQ is gonna unzip into my JBoss AMQ folder. So this is my my JBoss AMQ. I'm gonna go inside bin and start it up. So this is going to start up my AMQ. So once we start up our AMQ, we're going to run our dashboard server. Our dashboard server is running on Jetty. I didn't want to write a camel and a fuse endpoint, camel fuse endpoint for that, because I don't want to get people mixed up, or we have to use fuse to open up WebSocket or something like that. So this is a pure Jetty web application. I'm going to show you right now. So open up my JBoss Developer Studio. It's not running. Wait, let me do it again. Check. So my AMQ has started. So this is my workspace for developing this messaging server. Let's see. Okay. I don't know why it's running so slow today. So this is my AMQP and it's a web example. So this is just a pure web application. So what I've done here is that I did this is a WebSocket endpoint, which is really obvious. And this is the model that I'm going to use. I'm going to collect 4 different type of body vital signs: the blood pressure, the breath rate, and heart rate, and the insulin pump. And all these are going to be gathered from the messaging queue. And all the informations were done by a producer producing a random data into the messaging queue, messaging as well. So after I started, so this is, and this is just a data random generation code. So the most important part is this messaging producer and message consumer. So as you can see, the message producer and consumers are all in just JMS code. This is normal JMS code, like creating a connection factory, start a JMS session, and create a consumer. This is pure JMS code. And want to see the producer. The producer is the same. It's all pure JMS code. So what I did is I put in properties that starts up the JMS, but you have to tell the JMS what kind of context factory that you're using. So what we did here is we're using the Apache Qpid library. So we're loading the Apache Qpid library to load the information. And the Apache Qpid library is also defined in my somewhere. Yeah, it's here. So it's also defined in my POM. So it's loading all the data in. So underneath that, we're using the AMQP by Apache Qpid to load the information in, and all the messaging queue and the queue names for my test codes are here. And the actual part is that how are we supposed to connect to the messaging server? This is the part where we put our messaging factory. It starts with AMQP because we're using AMQP, and we have to set the users and the password in front of the IPs that we're using, and with the test with with the broker list. I was trying to test on the failover, but I haven't started yet. But I'll show you my result but I think somehow the failover has some problem, but I'm gonna check it out for you. So this is the settings that I'm gonna use for that. So mostly this is my code now. So just get started, run. Oops. No, we have to go into the project. Now we go to the AMQP example lab projects where the pom.xml is. So we're gonna start again. The run. So this we're gonna start up a web service. Okay. Now, okay, so it started. So what we did here is we are going to so if you at this point you can go to the localhost 8282. That's the port I set it in, so it doesn't crash with your other systems. So this is the page that you're going to see here. It's going to have an explanation page that says what I'm doing in this demo and the different graphs that it's going to collect all the information in. So I'm going to press the start button. If I press the start button, what the message here is going to say, like, I'm going to send different informations into the messaging server, and the once the server gets the message, it's going to send it back to the console. So I will be able to see all the informations that I produce. For the producers, I would what I did here is I created different threads. So I have different threads of sensor. They are sending it in a different pace. Well, currently I set it into the same pace, but you can put it in different pace, like different gap in seconds. So it's sending out all the informations from the thread to messaging server. And here, if we go to the hot IO, this is the JBoss monitoring console, or the management console, which is the hot IO. It shows all the stats. So here we're gonna see all the data coming in and the message going out from here. And with the diagram, we're able to see that there is a connector connecting back. Well, it jumps back to the stats when it changes. So we have different connect. We have a diagram showing that what different connector is going to connect in. So it's sending all the information and it's getting out. So this is I think I did it very quick. So I think this is it for my what was the question? As the airport and airline adopt AMQP. Yeah, I think that what they did is AMQP 1.0 protocol, but I have to check for you. And if you want, I still have another example that's doing MQTT. What I have here is if you go to my if you go back to my my GitHub, I have another MQTT demo. Well, this demo goes connecting to the XPath and my MQTT client. And what I did is my client is produced by it's using the API from FuseSource that was done like a few days ago. So no, 2 years ago. So let me change my workspace. Yeah, that's right. You answered my question. Yes, MQTT is supported in our current versions of AMQ. So MQTT is already supported. This is my MQTT demo. The MQTT demo is using the it's using the MQTT client API that was published out, and it's currently 1.11. I'm not sure what's the latest version, but that's what I'm using. And because MQTT is a lightweight publish and subscribe model, so it's not a queue thing, it's a topic thing. So what we did is we have created a client that's you have to set your host protocol and your username and your password for it, and after that you can just connect it with your API. So what happens is what I can do is I can show you as my MQ demo is that where am I? I could quickly change the let me restart my AMQ and add my MQTT protocol in. So all this is in etc. What I'm going to do is I'm going to do MQTT protocol here. And what port did I use for my example? I used 188. Up. And let's go back to our console. Oops. What did I do wrong? I think I did something wrong with the MQTT. Let me check. I added this because I have too much time left. So let me go back to my QTT. Yeah, that's what I did. Is it TCP? Maybe. So the MQTT is supposed to run now. Let me see if it's working. Oops, it's not. I think I need to check with something else. But what I did here is well, if I think it's MQTT, but I'm not sure why it's not working right now. But it's supposed to work. Maybe it's the version I'm using. But after that, I will it will run the just run the consumer and the producer. It will just connect to the MQTT and starts propagating informations inside. So that's it for my sharing for MQTT. But just give me few minutes. Yeah, that's what I did. I'm not doing the right directory. Yeah, it's not picking up my messaging server. So it's because this happens when the fuse message console doesn't pick up the AMQ because there's something wrong with your messaging queue XML. So this is what it happens if you're not configuring right. So I'm not sure why this is happening because this didn't happen before, but well, I'll get an update for you guys then for this. No, it's not my username and password because it's admin. So I'm not sure what's wrong with it, but yeah. Because this is where you sit the MQTT and AMQP path, the connector, and this is supposed to set your username and ID password. So that I don't think it's the ID password that's getting you in the problem. So okay, so is there any other questions? Oh no, supposed to have an AMQ on top of the thing. So if we go back to our original settings, it would have AMQ on the left corner. Maybe I should clean my thing, right? See, this is correct. This is how it's supposed to look like. So maybe it's the cache, because what they did with the hot IO is that they did a lot of scripting in their console. So I cache a lot of my stuff in my browser, so sometimes it's not rendering right. Maybe that's the problem. I did that's what I did. Show you guys. Okay. Well, I use Chrome. The Safari sometimes go crazy. So, so now it's working. Strangely, I think it's the cache in the browser. You know, I hate it when that happens. I'm sorry, guys. Okay. So what are the well, while I'm starting this so what are the competitors that are in the Internet of Things? I think mostly I meet is the RabbitMQ and the mosquitoes that I see them a lot. Thanks. But mostly it's what I've seen, and the MuleSoft has a lot of things. They were talking about the Internet of Things a lot in the space, but mostly they're focusing on the ESB instead of the messaging itself. So does that answer your questions? So for MQTT, just run. So I'm starting a consumer connection refuse. Whoa, what server did I put? And I need to change my admin. Minus. So I've connected to the to my MQTT server, so it's now receiving information from MQTT, and I'm going to create a producer. So the producer is going to produce information, sending out informations. So I'm getting and sending information from the same time, if you guys can see that. So this pretty much ends my session today. So it's sending all the information out. This is my producer, and my consumer is getting all the information from MQTT. Okay. So is there any other questions? If not, we're ending this session. I'm sorry about this bug thing. I'm so sorry. Okay, so if not, I'm ending this session. Thanks.